Final thing that we'll take a look at is this concept of scale. We can either scale up or we can scale down. And the key here with scale is that scale is proportional. Okay, so we can either divide scales or we can multiply all the numbers by the same thing. So we could divide everything by 2, or we could multiply everything by 2, or by 3, or by 4, or by 6, or by 7.62. Okay? Whatever it happens to be, you can change the scale. So let's say, for example, that the dimensions that are inside this red box are my standard dimensions that I'm going to work with. And I can scale up or I can scale down. Okay? So if I want to scale down, and you scale down when you're dividing, okay, I would divide everything by 2. So instead of it, I would take 2 divided by 2, and so this becomes 1 wide times 2 long times 1 high. Okay, so I'm just scaling this. In this case, I've scaled down. I can also do the opposite. I can scale up, and when you multiply, you're scaling up. Okay, you're making it larger. Just like if you're making popcorn, right? If you have a single person, 1 bag of popcorn is sufficient. You just use 1 bag of popcorn. But if 3 people show up, then you want to scale up your amount of popcorn so you get 3 bags of popcorn. Okay? So in this case, I'm going to scale up, and I'm going to scale up by 2. So that means I'm going to take all of my dimensions that are in the red box and multiply them by 2. So now I'm going to go 4 wide by 8 long, again by 4 high. Okay, so as a matter of scaling, you're just basically being proportional. And so all of these things are proportional. Everything in the blue is divided by 2 from the original that's in the red box, and everything in the green is scaled up, is proportional because everything is twice as large as it was in the red box. So in terms of scale, it's just multiplying or dividing every one of the dimensions by the same value. In this case, we did it by 2, but we could do it by any other value that's out there as well.